watching the live web stream of the James Webb Space Telescope launch. The stream is coming live. The weather there is, as you can see, the weather is slightly cloudy, but at the last announcement, we were informed by the update from the French Guiana Space Station is that we will be launching the all-in-one James Webb Space Telescope. It's the most advanced space telescope which has ever been. So it will be the most advanced telescope in orbit of space once it is launching. So what is this James Webb Space Telescope? What's the science it's going to do? Let's understand. This is the most advanced, one of the heavy lift launchers, Ariane 5. The launch pad is in French Guiana, it's in South America, it's by France. And the advantage of this launch pad from where the James Webb Space Telescope will launch is that it's on equator. So we would have the Earth's orbit. As the Earth is right now orbiting, it helps rocket move in the eastward direction as it launches. So it makes a little bit of, it makes it easier for us to launch the rocket. Let's see what's the science which the James Webb Space Telescope is going to do.
The deeper we look into space, the farther back we see in time.
Light travels 670 million miles an hour, but even at this speed, light from even the closest big galaxies takes millions of years to reach us.
Looking deep is looking back to when the universe was younger. Right now, our best tool for viewing the young universe is the Hubble Space Telescope.
This is Hubble's deepest view into space.
The universe was younger. Right now, our best tool for viewing the young universe is the Hubble Space Telescope.
This is Hubble's deepest view into space, known as the Hubble Ultra Deep Field. Here, astronomers have found galaxies so far away that their light began its journey to us more than 13 billion years ago.
We're seeing these galaxies as they were when the universe was just 600 million years old.
In human terms, this discovery is comparable to a teenager looking at a 6-month-old baby.
But for these galaxies, the universe was no nursery. It was more like a brutal football game.
The earliest galaxies were small dwarfs, smaller even than the ones Hubble has seen. They grew by colliding and merging with other small galaxies, as shown in this simulation.
Over billions of years, these mergers built up the giant galaxies we see today. Mergers triggered pulses of star formation that created the elements necessary for planets, and ultimately, life. But to see beyond Hubble, to witness the origin and development of galaxies, astronomers need a new tool. This is Hubble's successor, the James Webb Space Telescope, which is now being built.
Its mirror, 2.75 times the size of Hubble's, and instruments are optimized for a part of the spectrum where the most distant galaxies shine, the infrared. Hubble sees infant galaxies.
The James Webb Space Telescope will see newborns.
So as we just saw, if we ask the question, do we know how the galaxies were born? You will be surprised. The answer is no. We still don't know exactly how the first galaxies in the universe was born, because no one has ever seen it. The James Webb Space Telescope will be the first telescope ever to look at the time when the first galaxies, that means imagine when you're looking far back into the time, these galaxies were born just as the universe came into existence 13.7 billion years back. So we live on planet Earth and there are so many galaxies. When you look at when the universe was coming alive, okay, I think there is some problem with my audio. Just checking. So, okay, I believe there is some problem with the audio. Please bear with us as we fix the problem. So when the first galaxies were being born, that's the era which the James Webb Space Telescope is going to be looking at. We will just understand, but it's almost time for the countdown, so we will switch back to the live stream by NASA.
Technique arms you can see on this picture. Then 3 seconds before the H0, the inertial platform that will give all the information about where it is to the launcher will be released, and at H0 the 7-second sequence to ignite the Vulcan engine of the main stage will start. That will take 7 seconds, a little less than 7 seconds, where the engine will start up to its flight regime. Once the computer has checked that the Vulcan engine is running normally, and you will see at that point the flame going stable at the outlet of the nozzle, and at that point the onboard computer will ignite the 2 boosters that will enable to move the 770 tons of Ariane and Webb.
Coming up on the T-minus 4 minute mark right now. Just a couple of milestones real quick. At the 1 minute 5 second mark into the flight, Ariane 5 will go through the period of maximum dynamic pressure, max Q as it's known. That will be the period of maximum aerodynamic forces on the rocket itself. The solid rocket boosters, which will provide about 90% of the initial thrust off the launch pad, will shut down and separate at the 2 minute 21 second mark into the flight, followed 1 minute and 5 seconds after that by fairing jettison. That will expose the James Webb Space Telescope to the environment of flight for the first time. The main stage separation, or the first stage separation, comes at the T-minus at the 8 minute 47 second mark into the flight, and that will be about a 16-minute burn of that upper stage engine. It will cut off at about 24 minutes 51 seconds into the flight, and then we'll go into a coast phase of about 2.5 minutes to allow any oscillations to dampen out, provide the most pristine environment for the James Webb Telescope before observatory separation. We're coming up on the 2 minute 50 second mark into the flight. Again, you're going to be hearing critical calls down the stretch here from the DDO, or the Range Operations Manager, Jean-Luc Voyer. The weather is go. We have a green board, no issues being worked. NASA officials, including Greg Robinson on the right, carefully watching the telemetry, looking intently at the final couple of minutes of the countdown. Lives have been spent in the preparation of the James Webb Space Telescope that is about to fly.
And Beatrice Romero on his side, on the left of the screen, from Iron Space.
And that is the DDO, the Range Operations Manager, Jean-Luc Voyer, as we have hit the 2 minute mark in the countdown.
The flight will be in 2 phases. You will see the first part of the flight during the solid rocket boosters phase. That will be the atmospheric part of the flight, the atmospheric flight. And the trajectory will be driven by to reduce the aerodynamic loss, and then we will have a very different exo-atmospheric flight after that.
And you were watching a number of people, VIPs and invited guests, moving out to the observation platform that is right next to the Jupiter Control Center as we stand by for the 1 minute call from Jean-Luc Voyer.
À tous les vidéos, attention pour moins d'une minute. Top, à 0 moins une minute.
Less than 2 minutes to
Thumbs
go.
up from Jean-Luc Voyer. All systems are go. We're inside a minute now. T-minus 50 seconds and counting.
It's 50 seconds.
As you heard earlier, the Vulcan 2 engine will ignite. Turbo pumps will come up to flight speed for 7 seconds, and the command will be issued to ignite the solid rocket boosters. The James Webb Space Telescope will be on its way. T-minus 30 seconds and counting. Standing by for terminal count.
À tous les vidéos, attention pour les décomptes finales. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top.
And we have engine start. And liftoff.
Décollage.
Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe. Punching a hole through the clouds, 20 seconds into the flight, good pitch program reported.
Trajectoire nominale.
Vehicle performance is nominal. The Ariane 5 rocket continues to fly uphill in nominal fashion. The rumble of the powerful Ariane 5 now being felt here in the control center. 3D animation.
We can hear the noise and feel the vibrations here. You're right, Rob. Yeah, impressive.
13 kilometers in altitude, 7 kilometers downrange, traveling about 0.6 kilometers per second.
Tous les paramètres à bord sont normaux.
The trajectory reported to be nominal by Jean-Luc Voyer, the range operations manager. You can see at the bottom of your screen the yellow line is the trajectory plot, perfectly overlaid over the green line, which was the pre-launch trajectory. 1 minute 41 seconds into the flight, about 40 seconds away from shutdown of the solid rocket boosters. Coming up on the 2-minute mark into the flight.
When it detects the threshold of acceleration, not the deceleration, but less acceleration.
Tous les paramètres à bord sont normaux.
Everything is okay, everything is normal.
2 minutes 15 seconds into the flight.
When the computer detects this threshold, it will separate.
Séparation des EAP.
Done.
We have confirmation of solid rocket booster separation from Jean-Luc Voyer. This coming at an altitude of 44 miles. The Ariane 5 and James Webb traveling almost 5,000 miles an hour. We have about 1 minute 5 seconds to go before fairing jettison. That'll be the next critical milestone.
The fairing is there to avoid the satellite being exposed to high temperatures and also high airflows. And as soon as the launcher leaves the atmosphere, as is now the case, the satellite does not need anymore to be protected, and Webb does not need anymore to be
Paramètres à bord sont
protected.
normaux.
So each kilogram being very important for the performance of the launch, we are going to eject this no more useful fairing.
And let's go down to the floor in the Jupiter Control Center to Raphael Chevrier of Arianespace. Raphael, so far so good.
Hi Rob, so far so good. Everything is nominal, as we say, when attitude and trajectory of the Ariane 5 is going perfectly well. As you can see also on the yellow
Langage de la coiffe.
on the screen, we had the confirmation of the separation of the two speed boosters and now of the fairing, meaning that we have crossed the limits of the atmosphere. So everything is going
Tous les paramètres à
super
bord sont
good.
normaux.
And the DDO just said that all parameters are going perfectly smoothly. So let's continue the mission.
And Raphael, this is a view from the upper stage camera called the VikiCam, looking back at the James Webb Space Telescope. This is on about a 20-second delay or so because the way the imagery is processed here in the control room. There's your telescope ready to unfurl its wings basically and begin its journey to it. The Lagrange point, the L2 point, about 1 million miles away from Earth.
La trajectoire est nominale.
Trajectory is nominal. The report from Jean-Luc Voyer. The liftoff time confirmed here in the Mission Control Center at 12:20 Greenwich Mean Time, 9:20 a.m. Peru time, 7:20 a.m. Eastern Time. The Ariane 5 and James Webb, 181 kilometers in altitude, 450 kilometers downrange from the launch site here in Peru.
Flight control is very smooth.
5 minutes, 12 seconds into the flight. We have about 3.5 minutes to go in main stage or first stage performance. And again, you can see at the bottom of your screen the yellow plot line overlaid over the green line, meaning we are right on course, right down the pike, and a perfect trajectory so far for the Ariane 5
Les
rocket.
paramètres à bord sont normaux.
All telemetry data are now received by the Galileo tracking station, which is close to here where we are in Kourou. It will track the launcher up to the ignition of its upper
Le
stage,
stage 4 de la propulsion est nominale.
and then we'll have the data station in Brazil, Ascension, as you can see on the map, in the middle of the ocean, and the two last stations in Africa, Libreville and Malindi, one on the east coast, the other one on the west coast. And the one on the west coast, Malindi, you can see that the telescope will be separated more or less over this Malindi. You can see both are green, Galileo and Data on this animation. It means they are expected to receive the data, and it was confirmed right now by the launch operations manager.
Acquisition de telles mesures par la station du Natal au Brésil.
And just confirming now that telemetry is being processed through the Brazilian tracking station. The telescope is also processing telemetry through the tracking and data relay satellite system. As it moves further and further out into deep space, all of the telescope's telemetry and its imagery ultimately will be processed through the Deep Space Network in Goldstone, California. We passed the 7-minute mark into the flight. A perfect ride so far on the Ariane 5. We have about 1.5 minutes to go in the first stage performance. Once the main stage engine is commanded to cut off, it will be jettisoned, and just a few seconds after that, the upper stage engine will ignite, and it will be the workhorse for a 16-minute burn that will put James Webb into its preliminary orbit. About 11 minutes from now, telescope controllers at the Space Telescope Science Institute will be sending commands to prepare James Webb for the initial series of commissioning activities that will lead to the deployment of its solar array and the initiation of generation of electrical power for the telescope. About 30 seconds away from main engine cutoff.
La trajectoire est normale.
Nominal trajectory continues to be the watchword for the day from the Range Operations Manager, Jean-Luc Voyer, as we stand by for main engine shutdown and separation.
Extinction de l'EPC. Séparation EPC.
And we have main stage shutdown and separation confirmed here in the Mission Control Center, and the ignition of that upper
Allumage
stage.
ESC.
And Raphael Chevrier down in the fishbowl. So far, so good.
Yes, Rob, we have the confirmation of the separation of the main stage and the ignition of the
trajectoire
upper
est nominale.
stage. The trajectory is perfectly nominal. This is a very important moment for us because it's always a challenge to switch on a cryogenic engine in space condition, and we are now at 220 kilometers of altitude. Speed is a bit more than 7 kilometers per second. As we enter now the second stage of the second phase of the flight, the upper stage is going to power for
Pilotage est calme.
about 16 minutes to place Webb on its transfer orbit, and right now everything is again nominal as the DDO just said.
And a short time from now, the so-called sawtooth maneuver will get underway. Again, like rocking a baby in a cradle, this will be a maneuver to keep Webb's optics protected from overheating, Luce.
Exactly, Rob, like baby in a cradle. You can see here Webb attached on top of Ariane 5 upper stage with a very specific configuration. Of course, it will be different during its lifetime, but for the time being, its sun shield is folded and not yet fully protected in the observatory. A number of exhaustive studies have been performed by the mission teams in Europe, in the US, on the thermal conditioning inside the telescope and the way the rays of the sun would propagate and interact with sensitive equipment inside the telescope. Maintain this thermal conditioning is really key before separating this telescope. And in particular, we know that one face of the telescope cannot face the sun. That's why to produce these right thermal conditions inside Webb, a specific roll law has been designed, what we call the sawtooth approach. And if you are watching carefully to these images, you can see this animation. You can see that the upper stage is going 30 degrees on one side, then 30 degrees on the other side, going back and forth this way to maintain this perfect thermal conditioning for the telescope.
It's worthwhile noting that after Webb separates from the upper stage of the Ariane 5 rocket, which continues to perform in excellent fashion coming up on the 12-minute mark into the flight, the telescope controllers will be taking the baton, if you will, from the mission controllers here in Kourou. The first steps will be the opening of fuel valves, a pair of fuel valves, to start flowing fuel to Webb's onboard thrusters. They then will power on the valve drive electronics. Those are powered on in preparation to control and fire those thrusters when required. Webb's solar array is scheduled to be deployed at approximately the 33-minute mark into the flight. Once it is locked in place, we'll get the call that electricity is flowing through the array. That call will come from the Mission Operations Manager, Carl Starr, who is at the Space Telescope Science Institute at Johns Hopkins in Baltimore. Seated right behind him in that control room is Alicia Starr, a pair of stars helping to guide James Webb on its discovery of the stars. Alicia Starr is the lead engineer for launch and ascent events. Once the solar array is deployed and declared power positive, then 3 out of the 4 hold downs for the aft deployed radiator will be released to prevent binding due to the cool down of the telescope's composite structure. The contamination control heaters will be enabled to protect instrument optics on Webb from any water ice condensation as they cool down. The actuator drive unit will be powered on. This particular mechanism helps with heater control of the fine steering mirror, preventing water ice condensation, later to be used to position each of the mirror's segments. All 6 reaction wheels and the wheel drive electronics will be powered on for Webb, and that will be the precursor to the attitude control system using those reaction wheels to maintain the proper orientation with the sun, as opposed to using onboard thrusters. Of course, fuel in those thrusters, very valuable. It's a limited commodity for the lifetime of James Webb's observations of the universe. We're 13 minutes, 55 seconds
Les
into
paramètres
the
à bord
flight.
sont normaux.
Jean-Luc Voyer, the range operations manager, continues to report a nominal performance for James Webb. And again, Luce Fabregat from the European Space Agency, how is this trajectory being carefully and methodically adjusted to provide the correct parameters in the final stages of ascent?
Yes, Rob, as you can see on this plot, the altitude is slightly going down. It's perfectly normal. The launch vehicle is really on the line where it should be. This decrease of its altitude, slight decrease of its altitude, will allow the launcher to benefit and the upper stage to benefit of
Pilotage
the
est
gravity
calme.
effect and to increase its velocity until it reaches a thermal threshold. It's about to reach it, or even already reached it now, and it will go up. And now it will go up and up to the separation of the Webb telescope. It will separate the Webb telescope on a highly elliptic orbit, but still around the Earth. The telescope will be released, inserted on an orbit around the Earth, with an apogee, a very high apogee above 1
Trajectoire
million
est
kilometers.
normale.
Trajectory nominal as reported by Jean-Luc Voyer. You see him in that view, 185 kilometers in altitude, some 4,500 kilometers downrange from the launch site here in Kourou, moving at more than 8 kilometers per second, right on the plot, right on the trajectory, everything looking great. We are about 9 minutes away from the completion of upper stage ignition. It's shut down, and then about a 2.5 minute
Le
coast
pilotage est
phase
calme.
before Webb will separate. Observatory separation will be called out. You'll be hearing those calls and the initial calls from Carl Starr, the mission operations manager at the Space Telescope Science Institute at Johns Hopkins, through solar array deploy and the declaration of a power positive spacecraft. James Webb, of course, will be traveling well beyond the moon to a distance of about 1 million miles away from Earth, settling into a highly elliptical, halo-like orbit
paramètres à bord
to
sont
begin
normaux.
its astronomical observations. And again, as we mentioned earlier, at the time of observatory separation, Webb will be at an altitude of approximately 864 miles, statute miles, traveling some 21,000 miles an hour. We're about 8 minutes
Tous les
away
paramètres à bord sont normaux.
from upper stage shutdown. The stage has performed as planned. No issues reported. The launch occurring at 12:20 Greenwich Mean Time, 9:20 Kourou time, 7:20 a.m. Eastern Time on this Christmas Day.
Very smooth
Le
launch.
pilotage est calme.
The velocity you just mentioned is very important, Rob. The velocity you just mentioned at separation of the telescope is very important. It will be slightly below, okay, I give it in a kilometer per second, but it will be slightly below 10 kilometers per second, because it's important that the satellite, the telescope, is not inserted on an escape orbit. It will be placed on a terrestrial orbit, so that there will be time for the layout,
Acquisition de la
for
télémesure par la
the
station de
early
Libreville
phase
au Gabon.
operations and the commissioning of the telescope. And that will be, in fact, the upper stage that will leave this orbit and goes toward an escape liberation orbit.
And of course, even though we're still in powered flight, the trajectory, the acceleration, the speed at which James Webb is going towards its preliminary orbit, all modeled in advance and carefully
Trajectoire
choreographed to
est normale.
maintain as quiescent an atmosphere and environment around the telescope for its ultimate separation from the upper stage of the Ariane 5 rocket, which is about 6.5 minutes from now. Eighteen and a half minutes into the flight. It's very quiet now here in the control center here in Kourou. NASA officials, European Space Agency officials,
La
Ariane
propulsion est
Space
nominale.
officials, all watching telemetry very carefully. And as the upper stage continues to burn nominally and sheds fuel, the acceleration uphill for the James Webb Space Telescope continues to increase as we approach the 20-minute mark into the flight. Again, upper stage cutoff is scheduled at the 24-minute, 51-second mark into the flight, about 5.5 minutes from now.
After the cutoff of this main engine, as you said, Rob, we will have a short ballistic phase, a short coasting phase that will, when the upper stage will rely fully on its what we call the attitude and roll control system, and it will adjust its attitude so that during this small ballistic phase, all the requirements from the telescope are fully met. And that at separation, when there will be the separation, the conditions will be very smooth and as requested for the telescope.
Le pilotage est calme, la propulsion est nominale.
Today's countdown was as flawless as you can imagine. The weather was perfect all the way through the early morning hours, through the fueling process of the vehicle. The weather's been a bit dicey here in Kourou over the past few days, but everything fell together on this Christmas day to send a new present to the world's astronomer. 20 minutes, 40 seconds into the flight.
Trajectoire normale, tous les paramètres à bord sont normaux.
All parameters nominal as reported by Jean-Luc Voyer, the range operations manager. 4 minutes of powered flight remaining.
The telemetry of the launch vehicle is acquired for the time being by the Libreville tracking station on the western coast of
Trajectoire est normale.
Africa. Flight control is nominal. The trajectory is fully normal, fully as expected, as you can see on the plot with the yellow plot over the green one that is the expected one.
From our broadcast booth high atop the Jupiter. 22 minutes into the flight here in Kourou. Joining me today for this less than 3 minutes of powered flight remaining. Head of infrastructure and
Smooth flight control.
European Space Agency. Luce, good morning. Great to be with you. Great to be with you today.
Very pleased to be here.
And again, as we've mentioned before, everything nominal reported by the range operations manager. As we've mentioned before, this is a long ride uphill for the James Webb Space Telescope to put it at the proper position in the sky so that it can escape from the Earth, basically head beyond the moon towards its final orbit for its commissioning activities that will be the dominant feature of all of the operations from the Space Telescope Science Institute over the course of the next several weeks. A major milestone.
And the launch operations manager announced the acquisition by Indy, by Indy station, as expected, for the end of the flight and the last part of the upper stage flight, separation of the telescope.
James Webb is about 4 minutes away from separating from the upper stage. And again, at that point, it will be on its own. And again, those milestones that we discussed a bit earlier in the broadcast will begin to be followed carefully by the telescope controllers at the Mission Operations Center, the MOC as it's called, at the Space Telescope Science Institute in Baltimore. One minute of powered flight remaining. The upper stage continues to function perfectly. It's been a smooth ride for the James Webb Space Telescope.
trajectoire est nominale.
That upper stage was loaded pre-flight this morning with 15 tons of propellant for this long 16-minute burn. Now about 30 seconds away from upper stage cutoff. And we're standing by for upper stage shutdown and the cutoff of the upper stage engine.
Extinction ESC. Tous les paramètres à bord sont normaux.
The extinction of the shut-off of the cutoff of the engine was confirmed exactly as expected, with the exactly expected altitude and speed and velocity. So now we have entered the coasting phase, the ballistic phase, that will last for a little more than 2 minutes.
And the telescope controllers in Baltimore confirming that all of the function parameters for the James Webb Space Telescope have been loaded on board the telescope. We are expecting Webb separation at the 27-minute 7-second mark here into the flight. Just over a minute from now, springs will gently push Webb away from the upper stage of the Ariane 5. As it moves further and further away from the upper stage, there'll be what we refer to as a collision avoidance maneuver.
Yes, Rob, exactly. The springs already will give some distancing, of course, between the two objects, between the telescope and the upper stage. And then the upper stage will leave the trajectory of the telescope and makes a special maneuver to pass the telescope and heads towards a liberation orbit and leaves the telescope on its orbit without any risk of collision and without any risk of pollution towards the telescope.
And we're about 17 seconds away from Webb separation.
Séparation Webb Space Telescope. Go Webb!
We do have confirmation of observatory separation. The James Webb Space Telescope, amidst applause here in the Mission Control Center, now taking its first steps in pursuit of cosmological discovery. It was a perfect ride to orbit, and all of the separation sequence events are running in good fashion according to the telescope controllers. And there is the view from the upper stage camera on the Ariane 5 looking at the James Webb Space Telescope as it moves gently away from its launch vehicle.
Fantastic pictures of this telescope.
Go Webb, go Webb!
Yes, go Webb.
Ironically enough, as we marvel on this view from the upper stage camera, this will be humanity's last view of the James Webb Space Telescope as it moves to its workplace about 1 million miles away from Earth.
Yes, you're right, Rob. Impressive, fantastic pictures. Yeah.
Now we'll be hearing shortly from the mission operations manager at the Space Telescope Science Institute, Carl Starr, who will be calling out the procedures that will lead to the deployment of Webb's solar array. And down in the fishbowl where there is jubilation, let's go to Raphael Chevrier of Arianespace. And before we do that, Raphael, a bit earlier than planned, but there is the solar array having been deployed. James Webb now has its array out as we stand by for confirmation that it is power positive.
Hey, Rob. J'entends pas ce qu'il me dit. Il m'a appelé ou pas? Il m'a appelé ou pas, Rob?
Non, il t'a pas appelé.
And there it is. There's your critical call. James Webb not only has legs, but it has power as it begins its journey and the commissioning activities to follow. And with that, let's go down to the floor in the fishbowl and Raphael Chevrier of Arianespace.
This is it. We have witnessed the confirmation that Ariane 5 have safely delivered Webb into space. The upper stage is now being placed on a safe escape orbit around the Sun, but honestly, I've got to tell you that these images are absolutely incredible, and well, it may be the end of the mission for Arianespace, but it's only the beginning of the journey for Webb. It's now on its way to the Lagrange point. Congratulations to all the team involved in the flight. Really, there is no words to describe the immersion that is happening right now in the fishbowl. So all I can say is good luck, Webb, and bring us incredible data from the deep universe.
At that point, our sequence will continue.
Well, Raphael, congratulations on a perfect ride to orbit from the Ariane 5 out of Kourou here today. A view here in the Space Telescope Science Institute. Their work just beginning on a new era of scientific observations. Luce Fabregat, it was a smooth ride to orbit. Everything went by the book, almost like a simulation, without any problems. And we thank you for all of your insight throughout the course of the day.
Thanks to you, Rob, and really a great achievement. I have many faces and names now coming up to my mind, and really you can be proud of what was achieved on both sides of the Atlantic Ocean. Thanks a lot to you.
Tremendous jubilation here in the control center. You're looking at Jean-Luc Voyer, the range operations manager. Quite a Christmas present for the world's astronomers as the James Webb Space Telescope begins its life heading towards deep space. With that, we're going to go back to the floor now to Katie Haswell. Katie, we did our thing. It's up to you now.
It's taken over 2 decades, thousands of international scientists, and billions of dollars to get to this monumental moment. The James Webb Space Telescope is finally ready for launch and could revolutionize our understanding of the universe.
I've been working on this project for 11 years. I have feelings of anticipation, worry, and also relief that we finally get to do what we've been practicing for years to do. It feels unreal, like it's not really happening.
Oh, it's real, and it should be launching in a matter of days, hopefully.
You have to build something as big as Webb to really get that capability to address some of these most fundamental questions we have.
Questions like, what did the first galaxies look like? How do stars and planets form? What are the key ingredients needed to support life on another planet? Webb has been in the works since the mid-90s, and today is an international collaboration between NASA, the European Space Agency, the Canadian Space Agency, and many other academic and industry partners. When it was first proposed, the telescope had one major goal: peer back 13.5 billion years to see the first galaxies. Light from those far-off galaxies has been stretched through our ever-expanding universe. By the time it reaches Webb's mirrors, it's stretched out of our visible light spectrum into the infrared region. So this is why Webb was designed to see infrared light.
Since then, the mission has broadened significantly scientifically. We now have 4 science themes: the first galaxies, galaxy evolution, the stellar life cycle, and other worlds.
That's a lot to tackle. So how exactly is Webb going to do all of this?
The James Webb Space Telescope will achieve these goals by 2 things. First, by being large, and second, by being cold.
So let's start there. If you haven't noticed, Webb has a massive, eye-catching gold mirror. It's made up of 18 smaller segments that will click into place after deployment and create a total surface area 6.5 meters across. For comparison, Hubble's primary mirror is only 2.5 meters in diameter.
You need this large mirror to be able to collect a lot of light. The more light you can collect, the fainter objects you can see.
And remember, the temperature of Webb is also key. The telescope has to be kept really, really cold. That's because if a telescope is warm, it can emit its own infrared wavelengths and disrupt observations. So to keep Webb at a chilly 50 Kelvin, engineers designed a tennis court-sized sun shield to block out light and heat from the sun, Earth, and Moon. To do this, the shield is made up of 5 layers, which insulates the telescope while allowing heat to escape between each layer. Then there's the infrared instruments themselves, which allow the telescope to do 2 things: observe objects that emit longer, redder wavelengths, like the earliest galaxies, and cut through the cosmic dust to see the nebula where stars and planets are forming. Using all this new and improved tech, Webb will be able to show us things we've never even seen before.
When you launch the telescope, it does all its science. It sends all this beautiful, enormous amounts of science data back, that you can do so many things. I mean, the amount of information that will be there is absolutely astounding.
So after countless hours of hard work, setbacks, and dedication, the James Webb Space Telescope is finally ready for liftoff. The telescope will blast off from ESA's spaceport in Kourou, French Guiana. The observatory will launch on the reliable Ariane 5 rocket, which is built to carry heavy payloads. Still, Webb's mirror will be folded to fit into the payload fairing. After liftoff, Webb will spend about 30 days traveling to the second Lagrange point, where the Webb telescope can comfortably stay on course with the Earth as it travels around the Sun.
Watch the launch, then follow us for about 6 months as we get everything ready. And please have patience during this time. It is really necessary to take 6 months to get everything cold enough, focused.
So it's going to take 6 months before we see the first photographs coming from James Webb Space Telescope. And what we got to know from scientists, it's going to be at least as fantastic as the Hubble Space Telescope's pictures. And one interesting thing is that it's going to be so far away, where it's going to go in the Lagrange 2 point, where there will be no possible servicing mission. So did you know that Hubble Space Telescope had at least 5 servicing missions? It was in low Earth orbit, but this telescope is going to be nearly 5 times the distance of the Moon. So imagine going so far where no astronauts can really go. Imagine, do you know that no astronauts have gone even to Moon after 1972? So this observatory is going to be placed further out. And it's a special place where it will be always be on the night side of the Earth, and there is a heat shield which we just saw. This heat shield prevents any heat. So I want you to imagine, I just want you to imagine, suppose there is a lot of noise in the room and you want to speak to someone who speaks really low. So imagine, okay, let me give you an example. What is this telescope going to do? Why this? What's this fantastic thing about this telescope? It's that, when the galaxies were formed, we live on Earth, but do you know that we are living in Milky Way galaxy and there are billions of galaxies? There was a time when the first stars lit up in the universe, and no one has seen that point of time. James Webb Space Telescope will be showing us that moment in time, in the history of the universe, when those first stars lit up. So that going to do that is really challenging, and the James Webb Space Telescope is a really advanced telescope. So how is it going to do that? Firstly, it uses a very large mirror. Let me explain you what are the challenges and why this large mirror, how we are going to look at that light. Why do we need why do we need a James Webb Space Telescope? So first of all, I want you to imagine that light from the distant galaxies, when when the Big Bang happened, there were no atoms at that time. Electrons and protons were there in like a soup, and it was like a cloud. Electrons then combined with protons, so you see the matter which we have around us. And when that happened, the universe became transparent and light could flow, but there was no stars at that time. So the universe was dark at that time, before the first star formation. And when the first stars formed, when you look at the things around you, you see them in the visible light. Okay, just look around you, you see everything emitting visible light. And the stars were also emitting this visible light, but now we can't detect that light with Hubble or any other telescope. We have to be in space, because imagine that the universe is expanding. Have you ever heard a train going? Have you ever heard a train going? So the train, when it passes you by, suppose there is a train which is stationary. So it is making a sound like maybe the train's horn is blowing. It will sound like Paw. Now imagine that a train is coming towards you and then moving. You are on a station, the train is coming and then it rushes past you. So how do you hear its sound? You don't hear it sound like Paw. You hear it Paw. So first there is a very shrill voice, and then suddenly the voice of the train siren, the horn changes. Similarly, what has happened as the galaxies in the very, very far away region of the universe, as the universe is expanding, just like a train which is moving at very fast speed away from you, those stars are really moving away at fast speed, so their light gets red shifted. That means whatever was the visible light now becomes infrared light. You know the spectrum, the different colors of light, the red, blue, yellow, the Vibgyor, the spectrum which you see in the rainbow. So what happens is that light becomes so stretched out that it's no longer visible to the eye nor the normal cameras. So that light from the distant galaxies can only be seen in special cameras. So you can imagine it's called the mid-infrared. So imagine, like right now I'm talking to you in English language, you can hear me, but thousands of years back, English language was spoken in a very different way. Over a period of time, this language evolved, and it is, you see it this way. The way I'm speaking to you, you can understand. But imagine, so language evolved. Similarly, imagine that light has shifted, and it's so much changed that to hear it, we need a special kind of camera with which the James Webb Space Telescope is carrying. Yes, Sheo, you're right. It's called the Doppler effect. And this Doppler effect has made, so now imagine that, when you will be going in college, you will get a picture of yours clicked with your college mates. So imagine that imagine when you see a picture of, when we take out the telescope and we look at the night sky, we are seeing these galaxies which are very evolved. But what happened billions of years back? Imagine now looking at all your friends when they were infants. That's what Hubble is doing. Hubble can look back. There is a very famous picture by Hubble called the Hubble Deep Field. We can't imagine the universe. We can't imagine ourselves without knowing that picture. It's a beautiful picture. Maybe some of you have seen it. And long back. So imagine like the Hubble is seeing the picture of the universe when it was an infant. And the James Webb Space Telescope will see the picture of the universe or the galaxies when they were born. So I'm sorry, I don't mean to say the universe, but the galaxies. When the galaxies were born, that's the time the James Webb Space Telescope will see its picture. And today we just saw the launch successfully carried out. And so I wanted you to imagine like why we need a big telescope. So imagine like there is a friend, you are on one mountain top and there is one friend which is standing on another mountain top. So he is screaming at the top of his voice, but still you will not be able to hear because there is a lot of different distance. So what you can do, so you might say, okay, the problem is like, okay, he needs to shout louder so that you can hear. There is one more thing you can do. You can increase your hear. Do you know animals have big ears? Do you know that elephants have very big ears? So they can hear even the faint sounds. So that is why the telescope's mirror is 6 meters. So it's much bigger than any telescope. You know, I am an astronomer, of course, working with Space India. And so imagine like I've used many telescopes, but these, like none of them, this compares to the size of the telescope which James Webb Space Telescope is having, a large mirror which collects its lots of light. So it can see even few photons of light coming. It's like having a very big ear. So you can see even a distant person which otherwise you would not have been able to hear because if the sound would be so faint, you would not be able to hear. But if you had a very big ear, you would be able to hear it. So we need big telescopes so we can see faint light. Imagine a person, imagine animals who can hear these faint sounds. So you can think like that. Now another thing you might wonder, when the sound is very faint, you need to really strain yourself and you really need to really need to be quiet yourself. There should be no sounds around you. If there is people making noise around you, if you're in a noisy place, first thing you want to do is you stand in a place where there is quiet. That's exactly where James Webb Space Telescope will be placed. So imagine, like, let me go back to another video which I showed you some time back, but because of the lag or the technical problems we couldn't see. But let's see this video. It explains this very clearly.
The deeper we look into space, the farther back we see in time.
Light travels 670 million miles an hour, but even at this speed, light from even the closest
The deeper we look into space, the farther back we see in time.
Light travels 670 million miles an hour, but even at this speed, light from even the closest big galaxies takes millions of years to reach us.
Looking deep is looking back to when the
So here we have these very beginning galaxies, so light from them will be very faint. So what I want to tell you is, so when you are in a room which is quiet, you can hear each other very clearly. Imagine. Now, why is this telescope going to a special place called the Lagrange point? The reason is that, you know, we talked about the infrared light. This light is like heat. So, just like heat. But now, Earth is also emitting heat, and in space, Sun is also emitting heat. So, if you have Sun and Earth very close, it's going to be really hot. And it's like you want to hear something faint, but because there is a lot of noise, you can't hear it. So we are sending this telescope to a place where one thing, it can always have one side towards the Sun and Earth. So it will have a heat shield. When this heat shield is towards the Earth, it is also towards the Sun. So no heat from Earth or Sun will reach it. So, and this heat shield will keep the telescope lenses and mirrors and equipment really cool. Imagine the coldest temperature in space is, yes, I have stopped the video so that I can tell you. So imagine the coldest temperature in space is minus 270 degrees Celsius. So this telescope works actually at very cold temperatures. Okay, because even slight temperature will will not be able to let it see the light. So that's the beauty of this telescope. It's so technologically advanced that it has to go to a perfect place. It has to have a very big mirror to be able to do the science. So what is it going to do? It's going to look at the newborn first, like the first light of the universe, like it's like light bulbs. When the stars lit up like light bulbs, the first stars, and when the first galaxies emerge. So imagine, like, okay, when I teach to students, one of the students asked me, I have a story to tell you. He asked me, how are galaxies born? And when I researched, I found that we really don't know how the first galaxies were born, because the bigger galaxies we see today are born by combining lots of smaller galaxies. But how did those smaller galaxies in the early universe form? Scientists know, they have an idea, but they have only computer simulations. They have only studied it through computers. No one has seen those galaxies. So imagine, we yet don't know how the galaxies are formed. Can you imagine? So that's the answer the James Webb Space Telescope is going to do. And now you must be wondering, when will we see the images? So it's a very complicated process. Today the solar panels have deployed, and then the deployment of the other structures of the telescope will start. It will complete in 1 month. It's like folded like an origami. It will complete in 1 month, and as the telescope is completed, there is a lot of mirrors packed inside it. So it's like a giant mirror, all folded. So they have to carefully align the mirrors. So it will take them, so they will open everything in 1 month, but the alignment and the focusing of the mirrors will take another 5 months. So the real data from this telescope we will get to see in 6 months. So we have to be very patient. So I hope that explains some science to you, and now I want to leave you with something which you can do. So this is for the kids. I want to show you something you can do. There is a website called JWST. Let me just take you to that website. Let me just finish this video first, and then it's a 2-minute video, so once I finish, I will take you to a website where you will be seeing how you can make a small model or paper model of the James Webb Space Telescope. So let's finish this video first.
Universe was younger. Right now, our best tool for viewing the young universe is the Hubble Space Telescope.
This is Hubble's deepest view into space, known as the Hubble Ultra Deep Field. Here, astronomers have found galaxies so far away that their light began its journey to us more than 13 billion years ago.
We're seeing these galaxies as they were when the universe was just 600 million years old.
In human terms, this discovery is comparable to a teenager looking at a 6-month-old baby.
But for these galaxies, the universe was no nursery. It was more like a brutal football game.
The earliest galaxies were small dwarfs, smaller even than the ones Hubble has seen. They grew by colliding and merging with other small galaxies, as shown in this simulation.
Over billions of years, these mergers built up the giant galaxies we see today. Mergers triggered pulses of star formation that created the elements necessary for planets, and ultimately, life. But to see beyond Hubble, to witness the origin and development of galaxies, astronomers need a new tool. This is Hubble's successor, the James Webb Space Telescope, which is now being built.
Its mirror, 2.75 times the size of Hubble's, and instruments are optimized for a part of the spectrum where the most distant galaxies shine, the infrared. Hubble sees infant galaxies.
The James Webb Space Telescope will see newborns.
So now, as I promised, this is for kids who will love it. if we go to jwst.nasa.gov, there is a model. If you look in features and activities on jwst.nasa.gov, on the top right there is a hamburger icon, and here under features and activities they have given a model of James Webb Space Telescope, and here you can download a really cool paper model which you can print. This kind of model, these are the parts for this telescope, and if you want to go a little more advanced, you can make this kind of model, and the parts can be downloaded here in the PDF format. So we hope you enjoyed the webcast, and on behalf of Space, I would like to thank all of you and Space India. So as I am Chief Technology Officer, and I want to tell you, Space India's mission is to spread scientific temper, and we believe we are changing the world by helping students. So as you know, part of my job is to communicate the cool science which happens in the universe by the scientists, and I also get to design various programs to make science easy to understand for students. So Space's job is to bring the fantastic science of astronomy and space exploration to you, and we have a website of our own called learn.space-india.com, where we have programs which you can join. Some of you may be already part. We have website is called learn.space-india.com, where you can join various programs such as the Voyager program and the iAstronomer program. Both are the really cool programs where you can learn astronomy, be a part of our clubs, learn. This is where you can learn more about our programs, and I'm sure you will enjoy. Okay, my screen is stuck as you were saying, so I need to show you the. Okay, this is the, like, okay, you saw this, but you saw that my screen is stuck. So this is learn.space-india.com, and let me just see if I can show you how to download the paper model. Okay. I was showing you the paper model by going to this place. If you go to let me see if, yeah, I'm sure you can see it now. jwst.nasa.gov. This is one of the paper model you can download from here. This is the more advanced one, and here there is a simple one which you can download from here. So how do you reach this paper model? See, this is the paper model, a really cool one. So if you go to jwst.nasa.gov, you will see this icon. Under this icon you will see features and activities, and when you click on build a model of Webb, there you will be able to take in the page which I have just shown you. So from the entire team, now I would like to thank you, and thank you for joining us. We hope you enjoyed, and let's be patient for the James Webb Space Telescope, and Merry Christmas, and wish you all a very happy New Year to all of you. Bye. This is Vikrant Naran signing off.